Polynomial long division today. So I have two little division problems set up, and if you can do these division problems, you're going to have a pretty good chance of taking care of polynomial long division. So let's just kind of first start off here. You're asking yourself how many times is 6 going to 1, and the answer to that is, well, it doesn't evenly. So we're going to take a look at then moving over one place and looking at this 19. How many times is 6 going to 19? Your answer would be 3. So now it is a multiplication. 3 times 6 is 18. Then we do a subtraction problem and come down. So you have 1. Then you're going to bring down your next value of 5. Now you are on to a repeat. Repeat exactly what you just did. How many times is 6 going to 15? The answer to that is 2. Now it is multiplication. 2 times 6 is 12. Subtraction problem, you end up with 3. You bring down your next value, and then you repeat it. How many times is 6 going to 30 there? You are saying 5. 5 times 6 is 30. It is a subtraction problem. You have a remainder of 0. So your answer would be exactly 325 times. Take a look at this. How many times is 6 going to 7? Your answer would be 1. 1 times 6 is 6. Do the subtraction, bring down the next value. 3, 13. How many times is 6 going to 13? 2. 2 times 6 is 12. Subtraction, you have 1, bring down your next value. 6 into 19. 3 times 18. Subtraction, and you have 1 left over. So it would be 123 times, and your remainder of 1 over what we are dividing by, which is 6. That is how many times it goes in there, 123 and 1/6 times. Now let's take a look at some polynomial long division. We're dividing x squared plus 2x minus 15 divided by x plus 5. Another way of seeing this problem may be like this. Those are both exactly the same thing, and we would set this problem up in this fashion. There you go. How many times is x plus 5 going to x squared plus 2x minus 15? You're going to be doing a lot of lining up these terms right here. Okay, but first things first, we're going to take this first term inside x squared, and you're going to take your first term outside and put it underneath. If you reduce that, you're going to end up with a value of x. So x plus 5 goes into these first two terms, x squared plus 2x, x times. That's what we're going to put up here. Now we're going to do some multiplication. It is x times x, which is x squared. X times 5, which is a positive 5x. Now, just like we did previously, this is a subtraction problem. Okay, the easiest way to do this will be to add the opposite. So come through and give everything a sign change in there. So now x squared and negative x squared cancels. 2x and negative 5x, we have negative 3x. We will bring down our next term of negative 15. And then we repeat that process. So I'm going to take this first term of negative 3x, and I'm going to divide it by my first term of x. When you reduce that, you end up with a value of negative 3. That will be what pops up top, negative 3. Now we repeat the process again. Take this negative 3 and let's multiply it by x. Negative 3 times x. Negative 3 times 5. We are subtracting, so come through and give it a sign change. Change the signs on everything down there. That cancels to 0, and that cancels to 0. We have a remainder of 0, and that's kind of a good thing here. So when we're doing polynomial long division, if you get a remainder of 0, it means it's a factor. So x plus 5 is a factor of x squared plus 2x minus 15. That's kind of a cool thing, because we have now found the other factor, x minus 3. So we could rewrite this original problem. X squared plus 2x minus 15 equals my two factors multiplied together, x plus 5 which we have demonstrated is a factor, and we now have our other factor of x minus 3. Kind of neat, huh? I like it. Let's do some more. X cubed minus 5x squared plus 11x minus 10 divided by x minus 2. Now when you're doing these polynomial long division problems, you need to have this in descending order. Descending order, both. And we need to fill in any missing terms. With a 0. So we have cubed, squared, x, and our constant. We have exponent of 1, and then our constant. So everything is taken care of. You're going to see this in action a little bit later, but this is a very, very, very important point that we need to keep in mind here. So we're going to take x minus 2, and we'll be dividing it into x cubed minus 5x squared plus 11x minus 10. So I'm going to take my first term here inside, x cubed, and I will take my first term outside and put it underneath and reduce that, getting x squared. So these two terms go into my first two terms, x squared times. Now I multiply that out. X squared times x is x cubed. X squared times negative 2, negative 2x squared. We're coming through with a sign change on this. Negative, positive, do your math, that cancels. We have a negative 3x squared. Bring down our next term of positive 11x, and then we repeat that process. My first term, negative 3x squared over my first term of x. You reduce that to a negative 3x. Negative 3x. Multiply that out, negative 3x times x. Negative 3x squared, negative 3x times negative 2, positive 6x. We are subtracting, so give yourself that sign change. Cancels. Here we have a positive 5x. Bring down my negative 10. Repeat your process. First term divided by my first term. You reduce that to get a value of 5. Positive 5. Distribute that, multiply it out. We get 5x. We get a negative 10. Sign change. Very good. Gone. It is a factor. Cool. So x minus 2 is a factor of that, and here is what is left. That is a remaining factor. You could find your other roots by factoring that, if possible. If not, quadratic formula. So we do know that this is a root. Any questions? Wish I could actually answer them. Alright, let's see where we're going to go next. How about 2x to the 4th plus 8x cubed plus 2x squared plus 3x minus 20 divided by 2x cubed plus 2x minus 5. So let's check for descending order and make sure all the terms are accounted for. 4, 3, 2, 1, constant. Perfect. 3, 1, constant. We are missing an x squared term, so we're going to have to fill that in. So when we do our dividing, 2x cubed plus 0x squared, filling in that missing term right here, plus 2x minus 5 divided by 2x to the 4th plus 8x cubed plus 2x squared plus 3x minus 20. There's our division. So we are looking to see how many times these 4 terms go into these first 4 terms. Alright, so I do everything that I've done previously. I'm going to take my first term of 2x to the 4th, and I will be dividing it by my first term of 2x cubed. When we reduce that, we get a value of x. So these first 4 go into these first 4 x times. Now we just multiply that out. X times 2x cubed, 2x to the 4th. X times 0x squared will be 0x squared. X times positive 2x will be positive 2x squared, x times negative 5x. We're going to do the math on that thing. Give yourself a sign change all the way across. Negative, 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 positive, and then bring everything down. Gone. 8x squared. Gone. Plus 0x. Is that right? Whoa, excuse me, that should have been a cube right there. So that is cubed, and that is my squared. Coming down here, I get, that is a positive and a positive, so I get plus 8x. I'm going to bring down my next term, negative 20, and I will repeat that process. First term of 8x cubed over my first term of 2x cubed. We reduce that, you get a value of 4, positive 4. That's what's next. I multiply that out, positive 4 times 2x cubed, giving me 8x cubed. Positive 4 times that plus 0x squared. Positive 4 there, we get positive 8x, and then a negative 20. We are subtracting, so sign change, bam. Let's see what happens. Hopefully everything cancels, and we will have shown that it is a root, a factor, excuse me. Fantastic. Remainder of 0. It is a factor. So we could actually take this and rewrite this problem. 2x cubed plus 2x minus 5 times x plus 4 equals this. 2x to the 4th plus 8x cubed plus 2x squared plus 3x minus 20. Those are the same. Do one more example here, then we'll be finished. Let's take a look at x to the 4th plus 3x minus 4 divided by x plus 3. We need to take a look at this and make sure that everything has been accounted for. So I see 4. I should have an exponent of 3, an exponent of 2 before my exponent of 1, so I'm going to need to fill in a couple terms right here. This has the 1 and my constant. So it will be x plus 3 divided by x to the 4th. We need my 0x cubed. We need a 0x squared. We have my exponent of 1, and we have our constant. There we go. Now we can begin our division. First term, x to the 4th, over my first term of x. Gives us x cubed. So my first two terms into my first two terms, x cubed times. Multiply that out, x to the 4th plus 3x cubed. Come through with a sign change. Cancel, negative 3x cubed. Bring down your next term, plus 0x squared. Repeat your process. First term, negative 3x cubed divided by x gives me negative 3x squared. Negative 3x squared times everything out front. Bam, bam. Negative 3x cubed. Negative 9x squared. Sign change that. You're canceling. 9x squared. Bring down my next term of a positive 3x. Repeat the process. 9x squared divided by my first term of x, leaving me with 9x. Multiply it out, 9x times x, 9x squared. 9x times positive 3, that would be a positive 27x. Sign change. Negative 24x. And you have canceled, bring by my next term of negative 4. Repeat the process, negative 24x, my first term, over my first term of x, giving me negative 24. Negative 24 times x, negative 24x. Negative 24 times 3, negative 72. Sign change. Cancel 0, and we have 68 left over, a remainder of 68. That means it is not a factor. So, one way of showing this is, hey, we've divided x plus 3 into x to the 4th plus 3x minus 4. Well, how many times does it go in there? It goes in there x cubed minus 3x squared plus 9x minus 24. This right here is a positive 68 over x plus 3. That's how many times it goes in there. So it doesn't go in there evenly, but if you were to take that and multiply it times x plus 3, it would take you back to x to the 4th plus 3x minus 4. Hope that helps. See you around.